Hey guys, all right, we're going to do Thursday, your DMR number 34 is your last day. So we're going to look at the tree diagram below. The problem wants us to find the probability that you will choose a t-shirt with jeans and sandals to wear. So the first thing we need to do is count the total number of outfits that you can make, and that will be the denominator. So this is one complete outfit, t-shirt, jeans, sneakers. So I'm gonna put the 1 beside it. You could also make t-shirt, jeans, and sandals. So I'm gonna write the number 2. And then I'm gonna go all the way down and label each outfit. 3, 4, 6, 7, 8, 9, 10, 11, 12. So based on the problem, there are 12 total outfits that you could make. Now, I want to know the probability of grabbing the t-shirt, the jeans, and the sandals. So I see t-shirt, I see jeans, and I see sandals, and I see it on here one time. I'm going to check over my list. This says t-shirt, jeans, and sneakers. This says t-shirt, khakis, and then sneakers or sandals. So again, I only see t-shirt, jeans, and sandals come up one time. So the probability is 1 out of the 12 outfits. Okay? All right, number 2. Which set of numbers is represented on this stem and leaf plot? So we need to take the numbers out of this stem and leaf plot and just put them into a list. So 0 and 5 is 5. 0 and 7 is 7. Are there any lists we can mark out right away? I would say D. D says that we had numbers 0, 1, 2, 3, and 4 on the stem and leaf plot, but we had 5 and 7. So, way to go. You already marked out a choice. All right, I'm going to keep going. 1 and 1 is 11. 1 and 3 is 13. 1 and 5 makes 15. 1 and 9 makes 19. Are there any lists that we could mark out now? I see that A is missing 11, 15, and 19. So I'm going to go ahead and mark that out. All right, now I'm going to keep going. All right, 2 and 0 is 20. 2 and 4 is 24. Is there any list that we can mark out now? It looks like we can mark out C because I see a 2 and a 0, which makes 20, but I don't see 20 on the list. Okay, and just to make sure that B works, we need to make sure it has 35, 40, and 43. And I see that it does. So B is the correct answer. Yay! All right. Number 3. Number 3 says, which choices below are equivalent to 1/5? So 1/5 equals 0.2 as a decimal. So I know right away 0.2 works, 0.1 does not. Okay, 3/15. I'm going to show you something. 3/15 can be simplified. It can be divided by 3. So 3 divided by 3 equals 1. And 15 divided by 3 equals 5. So they are equivalent, which means that one is true. Okay, let's try 4/20. 4/20 can be divided by, let's say 4. 4 divided by 4 is 1. 20 divided by 4 is 5. Ooh, so that means that that one is also what? Equivalent. Good job. Okay, I know that 1/5 is equal to 2/10 or 20/100, not 15/100. And then 1/10 is equal to 0.1, and that's not the same. Okay, so there's your 3. Got them? Take a screenshot if you need it. All right, number 4, we're going to look at a table together. The table below shows the number of miles that Joe runs each day of the week. If he runs this every week for 14 weeks, how many miles will Joe run? Okay, this is a multi-step problem. First, we need to figure out how much does he run in 1 week? So we need to combine Monday, Tuesday, Wednesday, and Thursday. And then the problem says he's going to do this for 14 weeks. How many miles will that be? Okay. So 2 steps. Step number 1, we're going to add Monday, Tuesday, Wednesday, Thursday. Okay. I'm going to get out my calculator. But if you're doing it on paper, just make sure you line up the decimals because you are adding. Okay, I got 1607. Hopefully that is correct. If I didn't get it right, you call me out in the comments, okay? Now, step 2 is that he's going to do that for 14 weeks. So we're going to multiply that number by 14. So times 14. And I got 224 9800th miles. It's a lot of miles, but he's going to be running for a long time, 14 weeks. Okay, awesome job for number 4. All right, let's tackle number 5. Number 5 is our fraction. It says Jack ate 1 1/3 cup of noodles and Pete ate 2 3/4 cup of noodles. How many cups of noodles did they eat in all? So that's telling me that we're going to add. So 2 3/4 plus 1 1/3. Okay, do they have common denominators? No. I know the common denominator between 4 and 3 is 12. Here's why. 4, 8, 12, 3, 6, 9, 12. All right, change your fractions. All right. 4 times 3 equals 12. So 3 times 3 equals 9. And then we're going to change 3 to 12. And we're going to do that by multiplying by 4. 1, 2, 3, 4. So we need to do 1 times 4. All right. Now we're ready to add them because they have common denominators. All right, so 9 plus 4, 9, 10, 11, 12, 13. 2 plus 1 is 3. All right, this is what I have so far. Now, you may be noticing that 13/12 is improper. It is 1/12 over a whole. So what I'm going to do is I'm going to, just to show you, I'm going to take out the whole, which is 12/12. And I'm going to put it with the 3. So that makes it 4. And then how much is left over? 1/12 is left over. So 3 and 13/12 can be rewritten. These are equivalent. This value and this value, they're the same. It's just that I removed the improper fraction. I moved over the whole, and then I had 1/12 left over. So 4 and 1/12 is how much he ate in all. Pete and Jack. So I'm going to leave that up for just a second so you can take a screenshot if you need the work. Okay? All right, love you guys. See you next week.